Hello everyone and welcome to Lee's R&D session number 8. This will be focusing on building a Unity compatible multi-threading system. Now Lee, what exactly are we going to be doing? Building a compatible multi-threading system? What are you getting at?
Well, there's lots of different ways that we could do multi-threading, but unfortunately, most of those don't work inside of Unity. So I guess you could kind of say this has been a lot of R&D as to figuring out if multi-threading was possible inside of Unity, because from hints that you find in the forums that yes, it is possible, though Unity doesn't support it at all.
Right.
So it was a lot of experimentation to figure out which of the multi-threading techniques would even work, and then kind of refining those to put together some sort of system that would facilitate being able to spawn off threads to do whatever we needed them to do. So the solution that we're going to be presenting in these videos is the result of all that research and all the experimentation. Now, even this solution is not going to be foolproof. By the end of these videos, I will show you exactly how this system can be used to make Unity explode every single time.
Now, you're not talking about your game per se, you're talking about Unity as in the editor.
As in the editor, yes.
Okay.
Because, and as you'll see when we start off this project, we're not even going to have Unity open. We're not going to code any of this functionality in Unity to begin with. We're going to start off with a console application. We're going to do our development and our testing initially inside of just Visual Studio with a console.
Okay.
We'll get all that working, and then once we've shown you the basic concepts of what we're doing and we put it all together, we'll put together a test, and we'll run the test, and we'll get some kind of a little benchmarking so you guys can see how this all works. Once we've got that complete, we'll move this into Unity, integrate it into a very simple Unity application so that we can show you it causing Unity editor to explode. Then, once we've demonstrated that, we'll take the very same code that kills Unity Editor, and we'll build a standalone program, and we'll run it from there, and you'll be able to see that the same things that kill the Unity Editor don't necessarily kill the runtime itself.
Yeah, I was going to say, basically what you're getting at is when you say build out a standalone, you're not talking about at that point a standalone like a console app. You're saying from inside of the Unity editor, we're going to build out that project that we've created. So it's like building out your game to a standalone.
Right.
And then we're going to run that, and that's going to run flawlessly. I mean, so far, you've done some pretty massive tests with the code built out to a standalone where you've run it for a lot of hours, correct?
Well, I think it ran 7 or 8 hours in the test that I'll be putting together. The test that I put together was spinning off 1 million threads, each of which that basically counted to 1,000 with a millisecond sleep time. So, 1,000 times 1 millisecond is 1 second. So the whole idea was that each thread ran for approximately 1 second, then terminated itself, and I ran 20 threads concurrently to process a job of 1 million complete worker threads. And that whole process took, I think, 7 or 8 hours, but it ran to completion outside of the Unity editor in a standalone Unity build. But that same project inside of the Unity editor dies at about 1,000 threads. Sometimes it's a little bit less, sometimes it's a little bit more. Just depends on how long Unity's been open when you decide to run this particular script. I might even have some fun with it, depending on where we are with time, and build it out to a web application and see what it does there, because that is one I haven't tested.
Okay. But we
So
haven't really been focused on nor planning to create a web app for what we're going to be doing with the MMO client. So,
yeah,
yeah, it'd be just having a little bit of fun just to answer a little bit of curiosity because you've not looked at that. But as
right.
far as the standalone, with all of the work that you've done, plus, of course, you've integrated this into the terrain system itself and you've run that on a standalone basis for a significant amount of time, you feel very confident that the threading system works very good as long as we do indeed build our Unity project out to a standalone.
Yes.
Okay.
So
That's obviously a very important one to make sure that we have indeed nailed down. Now,
right now,
getting this multi-threaded system into place inside of the terrain system, a lot of people that may have skipped a video here or there or just really wasn't paying close attention when we talked about some of the slowdown glitches that they feel right now with the terrain system as it is without multi-threading in it. This is going to be addressing that, right?
well, towards the end,
Yeah, not at the
this
beginning, of course.
right. The multi-threaded system wasn't designed specifically to solve that problem. It was designed to solve the problem with any job that you don't want to be running synchronously inside of an update.
Mm-hmm.
So this was designed to break anything apart. Now, the very first thing that I put it to work for, because I developed the system outside of the MMO project itself. This is a carryover from one of my other experimentations.
Mm-hmm.
And I brought it in and because it was really useful. And you'll see as we go through why it was written this way. So we could use it for literally anything. And so I brought it into the MMO project because when I was doing the initial R&D, the terrain patches do have some hangups, especially the larger patches you go with, and the more of them that you're trying to generate, they will cause some visual glitching inside of it. And many people in the threads are discovering it. And I've been asked repeatedly about it, and several people who probably just missed something are wondering if they've done something wrong with their code. No, they haven't. It's just that there is a very big performance hit that you incur when you try to create a mesh collider in real time inside of Unity. And even beyond that, generating the terrain using the procedural generation using the noise height maps.
Yeah, another big performance
is
hit.
Another big performance hit. Now, we can fix some of that. The calculation of the terrain patch by running asynchronously with these worker threads in the multi-thread system we're putting together will fix that particular problem.
Mm-hmm.
What we'll find, though, is it doesn't fix everything because we'll still hit a small glitch.
A much smaller glitch, but it's still a little hiccup.
Yep, it's still a little hiccup that we just cannot get around as long as we're trying to use mesh colliders based off of our terrain meshes. Because every time we hit that, we get a deferred performance hit inside of Unity that we can't get around. The only thing we can do is try to minimize when that hit happens. So we can try to spread it out, make sure that we're only generating one new mesh collider every so many frames, and just try to smooth it out the best we can do. Now, with the threading system, there's a couple of things that I had alluded to earlier, and the fact that we're designing this not so much just for the terrain system. We're designing this system to be a generic type system that you can use to queue up any type of thread that you need to do asynchronously with Unity. That means we're going to have a queue that we're going to be able to line up our jobs in order of priority and allow the system to allocate which threads get created when and coordinate all of the running. So you'll be able to have low, medium, and high priority threads, and being a queue, it'll be first in, first out, but higher priority threads will take precedence over lower priority threads.
Okay.
the threading system works off of a thread pool, which means we'll be able to dictate how many threads we want the threading system to be able to manage at one time. And then it will monitor its thread pool and make sure that as long as there are jobs inside of our queue and there are available threads, those jobs will be allocated to threads and those threads will be executed. And the whole process will continually monitor itself, clean up after itself when need be, and then go into an idle state once all the jobs have been completed, as well as shut itself down at the end of the application.
Now,
So,
talking a little bit more about this thread pool, are we going to be using the one that is provided with .NET?
no, this is one of the ones that I had initially tried to, but one of the things that I found out is Mono doesn't fully implement all of the members inside of the My Thread pool. So I ended up rolling my own.
Okay, so we'll be creating our own thread pool.
Right. So we'll do that. We'll also, another thing, .NET does not have a type for a priority queue. There is a type for a queue, and we'll be showing you that, but we won't be using that either. We will be rolling our own queue, but it will be a priority queue as opposed to a straight up queue.
Right, and this priority queue, again, designed as a standalone type system that could be used in other projects as well?
Yes, it is a separate component in of itself. We do not have to only use it with the thread pool. You could break it apart and use this particular class, instantiate it, and use it anywhere where you needed to prioritize anything.
Okay.
So that's what we'll start off with. We'll build this first. We'll demonstrate how it works without even having a thread system in place. So we could use it to do anything like control the output of text to the screen, or the ordering of whatever we send into it, as well as demonstrates how a queue works, because a queue works slightly different than most of your other data structures, like a list or a dictionary, where something is random access and it continues to stay there. Something with a queue, you can only get access to the next item in the list. So you can either look and see what it is, or you can basically dequeue it or pop it off, or it's not so much popping it, it's dequeuing it. So you pull the very first item off, but once you do that, that item is removed from the queue and you can't get it again. So, and you also don't have random access to it. So you couldn't go in and see that your queue has a size of 50 and go, give me the 21st element in the queue. You can't do that. You only have the ability to get to the very first one. So we'll look at how that is all set up, how that works, and how we will use regular generic list to be able to mimic that functionality.
Okay. Are we going to use generic lists, or are we going to use generic linked lists?
We're going to use generic list.
Okay.
Because I do not want any ordering applied to our list, other than the fact that I want the list to maintain the order of which we put the job in. So as you put something into a list, it's always adding the next element to the end of the list. So if I go, give me element 0 of a list, it will always give me the very first element that was put in. And then if I remove that, the second element that was put in becomes the first element. Okay. So as long as I'm always accessing it in that mechanism, it acts just like a queue. But with a linked list, you have the ability to add first or add last. And I don't need that functionality, and I don't want that behavior at all.
Okay.
So.
All right. Well, it sounds like we've got some interesting things ahead of us to get designed. So with that, we can go ahead and wrap up this introduction to what we have planned here in session 8 and get rolling. First up being, of course, the creation of the priority queue. So thanks a lot, ladies and gentlemen, and that will conclude this video.